Hello and welcome back to my channel. So today we are going to continue with concurrency. There's a good bit to cover, so today we're going to have a look at an example, and what an example we have today. So thank you so much to the people that have subscribed so far. Please continue to subscribe so I know to make more videos, and I'll put more up every week so far. Next week is a break from videos and we will continue again after that. So, and again, the previous video went up actually on the Monday, not the Sunday, and it was meant to go up on the Sunday, so apologies for that in advance. I hope not many noticed. However, we'll continue today. So we're going to talk a little bit about thread synchronization. So when you have multiple threads, they share an object. So let's say we create a new object. We always have like a new here. This is us creating a new object. We're going to go to simple array in a bit. So this is us creating our new object, and we're passing through 6 as the value. So our constructor needs to also reflect our simple array. So when we go to simple array, we should expect a value, an integer value, to be passed through here in one of the constructors. So when multiple threads share an object, it's modified by one or more of them. So indeterminate results may occur. So this basically means that we need to access needs to be managed, because the shared object, either when it's being read or updated, may produce different results. So we can't trust the program's behavior. So what we can do though is allow things like exclusive access. So when you have exclusive access, it means that only one thread can deal with it at a time, and all the rest of the threads then are put under wait. So they're all waiting. So when the thread is with exclusive access finishes accessing the object, then the waiting threads then proceed. So this is called thread synchronization. And then also we have, by synchronizing threads in this manner, you can ensure that thread access a shared object excludes all other threads from doing so simultaneously. So that's called mutual exclusion. Those of you who did logic gates will already know things like mutually exclusive. Anyway, aside from that, we have immutable data. So actually thread synchronization is necessary only for shared mutable data. Mutable meaning changeable data, and we mentioned that mutable and immutable, I think, back when we were talking about the final keyword. If you're unsure, please check out that video. And basically mutable means that the data can be changed over its lifetime. Immutable, it will not change. So then what do we do to indicate that it won't change? We use the keyword final. Labeling object references as final indicates that the reference will not change, but it does not guarantee that the referenced object is immutable. So this depends entirely on the object's properties, but it's still good practice to mark it as final because it won't change. It's supposed to not change. So it's immutable if it's not changing. Mutable meaning changing, immutable meaning not changing. So a common way to perform synchronization is using also monitors. So we can have every object then has a monitor and a monitor lock. And monitors and monitor locks can then enforce things like mutual exclusion. So when we have things like the synchronized statements and using the synchronized keyword itself, we can use this. So today we're going to just have a quick look at something that is unsynchronized, and then in the next video we will continue with the examples. So here, if we look at the shared array test, because this is the main entry point of the program, so we have our shared object being created, shared simple array. Now I'm going to flick over to simple array to show you. So here we have our simple array class, we have our secure random, generating a random number, and we have an array. As you can see, the size is not determined so far. And we have our private int right index. So for each of these private, if we want to access them, we also need getters and setters as well. However, we continue to have our simple array constructor, and as I said in the previous part, we have an integer of 6 coming in from our shared array test. So 6 is then being passed in and assigned as the array length, size of the array even. So public void add then is our next method, and we also pass through a value to this. We have our right index, assign it to position, and then we have our try catch blocks, and as you can see the way it's written, it makes it easier to find the block itself and the block here as well, just so you're aware. So when you are writing things out, you can spot things a little bit easier, more easily when you're writing it. So as you can see, we have our simple array. With our simple array, we have our add method. We have our unsynchronized mutable data sharing. So we have our simple array, and then we have our add method with our try catch blocks. And here we should add in thread dot, and to catch the current thread, and then interrupt it, and this will re-interrupt the thread. Someone asked me recently about comments, when you put in comments in code and what is the best practice. These are demonstration videos, so I purposely do not have a lot of comments in the code, so it's easier to read. When you are working in a workplace, a lot of programmers and a lot of developers stay for 2 years, 3 years. Some stay for a lot longer depending on the company. Usually it's 2-3 years in let's say American companies, 2 or 3 years. In other companies longer. It depends on the culture of the workplace as well. And if you can continue learning there and continue growing, etc. So, but you do move on projects. If you're not moving company, you might move projects. And when you hand it over to someone else, it's good to have good code that's clean, of course, but commented so people know why you did what, when, and why. Sometimes in code there can be a little bit of I want to say hacking based on hardware solutions at the time, of workarounds that happen, of limitations that are involved and things like that as well. So just to keep that in mind when you're going through it as well. So we have here our array position then, and our value. Then we print out our current thread with the get name and the value and position. And then we've used our, of course, here, beautiful override methods, which you can get in the source menu as well. So it first obtains a reference to getting the currently executing thread here. That's important. Then uses its get name method to obtain its main name, and then writes each here array is now being used the toString, which is great, which we know already is the override method. When we go back to shared array test, then we of course create 2 array writers. So our 2 array writers then, if we look at array writer, let me save this first. We have our array writer here with our start value. With our constructor first, we have our 2 variables, then our constructor, which uses the private instance variables using our final keywords here and here. And then we have our run because it implements runnable. And so when I go back here, we use these shared simple array objects that are just created. So our array writer takes a value and takes the array, takes a value and takes the array, and we call them writer1 and writer2. We call again our exec service. So our new cache thread pool, it creates a thread pool that creates new threads as needed, but will reuse previously constructed threads when they are available. And we execute them. Important to note that when we execute them, we also need to shut them down. If you remember in the previous video, I said every time you execute something, you need to shut it down. So we also need to go shut down here. That's an important one. So then we have a try block here, tasks ended. So we have our await termination, which is going to be a Boolean of yes or no and passed into this Boolean as well. So if it is true, then print out these, otherwise timed out while, and catching the interrupted exception as well here with our catch block. So as you can see, the way it's written, again, our try has a fully one block and our catch has another one block. So if I run the code, bring up my console, and you can see here each of the pool thread wrote 1 to element contents of simple shared simple array, shared simple array. Maybe I could format the the way this is written. Hang on. And run it again. So the executor service method shutdown returns immediately. So with that, then we always have there's contents of simple array shared simple array, even though the contents now is not written out, so we need to make sure that it is written out. So if we look again at where it's written, we can see here printed contents of shared simple array should be printing out. So I'm just going to have a look. Mistake here. Shared simple array. Instead of passing through the object, I put in quotes. And I also just added another line here as well for next write index. Just cleaned it up. So now when we run it, save the resources, and you can see the contents of it. So you can also see the next write index. So that is it for today. I'm going to keep the videos quite short. We'll go through a little bit more detail about this example next week, not next week, the week after. Thank you so much for watching, and thank you so much for all the subscribers. Please like, share and subscribe so I know to make more. Thank you so much. Stay safe out there. Bye.